Yeah, it's biochemistry time. Some terrible evildoer gave you biochemistry homework on your summer homework. So how are we going to accomplish this? Well, we'll need to be able to access a periodic table, and then the instructions for this should kind of include pretty much everything you need. So periodic table, something that's got the mass numbers here, and those mass numbers, for just a review of chemistry, is how many grams per mole of something there is. Back to Avogadro's number, the way we count atoms in chemical reactions is per mole. And for instance, if we have a mole of boron, which is 6.022 times 10 to the 23rd atoms of it, then that will have a mass of about 10.811 grams if we go with the average mass of boron as it is found in nature. So you'll need your periodic table, and let's take a look at the worksheet. The worksheet gives you a couple of bits of instruction. So some definitions. Molarity, and you've got is moles of solute per liter of solution, and that's what we're gonna try to attack here. So the first problem is looking at what's the molarity of a solution. We've got 10 grams of H2SO4, which is sulfuric acid, mixed with some water, and we end up getting a total of 0.100 liters of solution. The zeros aren't super important except for significant figures. So we've got our definition right here. We need to figure out how many moles of solute there are. Solute is the stuff that is getting dissolved in the solvent. H2O, or the water, is the solvent. It's the stuff that does the dissolving, and the stuff that gets dissolved is the solute. In this case, sulfuric acid, or it could be salt, sodium chloride, something like that. Would be probably a simpler problem. So we need to figure out how many total moles of this sulfuric acid we've got. So this is going to be a pretty basic chemistry equation. We'll figure out how many moles there are divided by the number of liters, which is 0.100 liters, and we'll have our answer. So we're gonna write moles of, sorry, I'm gonna start off with grams. We've got 10.0 grams of H2SO4, and we are gonna use a conversion factor to convert this. We've got grams right here. We're gonna put grams on the opposite side of the fraction so that we can cancel them out. And we're trying to get moles. So how do we know how many grams per mole there are in sulfuric acid? Well, you'll notice on your periodic table there's not a sulfuric acid box, but you do have all the ingredients for it. You've got hydrogen, 2 of those, sulfur, which is over here, and oxygen. So all we need to do is add together the components of those. So each hydrogen's got a mass of, this gives us more precision than we need, 1.007. So since we don't have a whole lot of sig figs in here, we can call that 1.01, which is fine with me. So 1.01 grams per mole again, but we've got 2 of those because there are 2 hydrogens. Sulfur, it's got a molar mass of, can't focus, 32.065, so we can call that 32.07 because I don't want to go too crazy. 32.07 plus there are 4 oxygens. Oxygen is probably one you memorized when you were in chemistry, 15.994. In our case, I'm not going to go that many sig figs, plus 4 sets of 16. So 16 times 4 is 40, 50, 64 plus 32. So that gives me 96, 97, 98. So I've got a total of about 98 point, let's see, 0789. Yeah, if I go real crazy on my sig figs, 98.09 moles, or sorry, 98.09 grams per mole. So 98.09 goes right down here on the bottom. That means for every 1 mole of sulfuric acid, it has a mass of about 98.09 grams. My grams I've already showed as canceling, so once I do this, multiplication and division here, I'm going to be left with moles. How do I do that? Well, 10.0 times 1 doesn't do anything, divided by 98.09. So I got 10.0 divided by 98.09. And we know that that's going to give me MOL, moles. This is 10, basically 10 divided by 100, so we know it's going to be about 0.1. We know it's going to be slightly more than 0.1. Let's see. I cheated and looked this up, or put this in my calculator already. You get about 0.102, so it's about 1/10 of a mole. What do we need to do with that knowledge? Go back up to the definition of molarity. It's how many moles of solute there are per how many liter of solution. So 0.102 moles divided by how many liters in the solution? Oh, it's just easy, 0.100 or 1/10. If you like fractions, or you can write the decimal here, 0.100. Dividing by 1/10 is the same thing as multiplying by 10, or you can put this into your calculator. 0.102 times 10 is 10.2, and that right there is your answer. That is the molarity of your solution. So it's 10.2 molar, and let's box our answer so we make sure we see it.